Greetings and welcome to week 6, unit 5. In the last unit, we understood the design of rubrics for large projects. And here in this unit, we will try to understand how to design rubrics for problem based learning. There is a lot to understand about the problem based learning before we move on to rubrics. Actually, the term problem based learning based approach now is being used in several broad senses these days because there are other uh, titles called inquiry based approach, active learning approach, experiential approach, and all of them can be considered to fall under the broad category of problem based approach. So you don't have to keep on getting worried about using these multiple terms. Now, the problem-based learning is a more common term in the literature now. One important thing is in any learning activity, there are three characteristics. First of all, whatever instruction that we do, it should be effective, it should be engaging the students in the activity, and then it should be efficient as well in terms of resources. So we call it E3 instruction. That is effective, engaging, and efficient. Now, as far as PBL is concerned, not all instruction methods are do satisfy all the three characteristics of instruction. And it is generally perceived that the PBL values effectiveness over efficiency. That is, you want to be something more effective rather than worry about the time and resources. So it is not, PBL is not efficient in terms of time of students and faculty and resources. So obviously, this will lead to to be careful about the resources and the scope of the problem. Historically, PBL was developed in the context of medical education right in 1969 in McMaster University, Canada. One formal definition of PBL is a progressive active learning and learner-centered approach where unstructured problems are used as the starting point and anchor for the learning process. That is a formal definition of given by one Tan OS. One can slightly alter the way wording is given, but the meaning is very clear here. That is what PBL should be doing. While it is very popular in medical education and allied areas, but is being used increasingly in several other domains also. What are the key principles of problem-based approach? First of all, formulate, I wouldn't say formulate, identify and provide authentic problems to learners. That means the problem should be meaningful, not just hypothetical. Like what we have at the end of the chapter problems, they're only test some concepts and some procedures. And the problems must be compatible with the intended outcomes. What happens is in a problem-based approach, you can simultaneously address several of the 11 program outcomes as given by NBA. How many do you want to address? So if you are choosing the POs that you want to address through this PBL, then what you have to do, you have to define the problem in such a way that all the corresponding POs are addressed. Now, teacher plays the role of supporting the development of learners' metacognitive skills and her problem-solving abilities. All of you, if you have gone through the earlier courses on outcome-based education, we have explained metacognitive skills there. Metacognitive skills means whether the student should know what he knows properly and what he doesn't know. That he must be very clear to himself. Not just merely say, yes, I have heard this, I know what it is, kind of thing. Then the other one is when you are trying to learn, you're going from point A to point B. Okay? Uh, the metacognitive skill consists of how to plan for your movement from A to B. That is, how much time you should spend, whom should you consult, what material you should read, what kind of practices you must have. You must be able to regulate your cognitive activities. So that is metacognitive skill, which is very important, and it is mainly learned at this stage of a formal program. So the teacher's role now is he will be tutoring rather than explaining the content of the problem. And to that extent, the teacher will have to get to save time, he has to get as many resources as possible, relevant resources, and make them available to the student. Yes, it requires considerable amount of planning by the teachers or the department to make this kind of thing available. And another key principle is after the work is done, after the problem, PBL, whatever PBL you are trying to solve, at the end, there has to be a stage of debriefing. That means you have to talk to each student to find out what exactly he integrated the key concepts gained from the learning experience. We will explain a little more about debriefing a little later. Now we have to talk about authentic problems. As I said, not necessarily the end of the chapter problems. Just because something is very large or many concepts are involved, that alone will not make it as an authentic problem. An authentic or a complex engineering problem will have multiple dimensions, multiple stakeholders. There are no obvious solutions, and any solution that you produce is likely to have different impact on the concerned stakeholders. Okay, so the authentic problem should reflect the cognitive demands that are consistent with the environment for which learners are being prepared. So what happens is the choice of the problem should be compatible with the cognitive levels of your students. So there is no point in just because in some other place where they have much better students and better resources to just bring that problem and incorporate into yours. Okay, so they have to be compatible with the learners and learning environment. But one characteristic of PBL is the problem is always ill-structured. In the sense, there will be some vagueness, and the students have to spend considerable time to convert the ill-defined problem into a more well-structured problem. In that process, you may be making several assumptions, and the assumptions may not be compatible with the requirements of your customers. So, one of the major issue is learners must be able to deal with this kind of ill-structuredness of the problem. And there should not be, scope of the problem should not be too small, because they should be complex enough to challenge the learners individually and as a team as well. Because this conversion from ill-structured to well-structured problem is a group exercise. And constantly a group discusses among themselves and tries to identify all the issues and then come to a conclusion. And also, they should not be purely hypothetical. Preferably, the problems must be contemporary and be able to excite the students. Okay. The, the problems are selected in that domain, whatever domain, let us say, the department is concerned with, are selected by the instructor in accordance with the intended outcomes and are then assigned to students. So the problem is identified. It doesn't mean that the problem uh, cannot be modified subsequently. But initially, for the students to kind of explore, the problem should be identified by the instructors, because this requires a lot of effort put in by the instructor in advance, and it is preferably done better by the whole faculty of the department together. And PBL is designed to support higher order thinking, and it is not appropriate for teaching basic skills. So it cannot be related to the first chapter of your textbook, nor at the very what you call elementary courses. The learners must be having some knowledge to start the process of engaging with the problem. If they don't have, then all the time they will be spending only in understanding the start of the problem. And possibly some of this material should be created in advance and made available to the students through the department website. Now, what is the instructor's role in PBL? The role is very critical for PBL, but it is not for lecturing on the content. It is mainly as a facilitator. That is, you have to guide the students in what direction they should explore, how should they come together, how should they come to a conclusion, and if they are missing some dimensions, then the teacher should identify and guide them accordingly. And tutor is not necessarily even the expert in the relevant domains. So the role is not even that of a coach actually. Also, the instructor should not or should ensure that learners do not stop their work too early. That is, they consider, yes, I have solved the problem, and whatever that is scheduled, let us say 3 4 weeks, say first week itself I have completed, and then uh, then the instructor should be able to guide them to explore it further. He focuses on group process to ensure the participation by all learners in the group. That is one of his critical role, namely to ensure that all members of the group are participating in addressing the problem. Further, the teacher will have to ensure that all learners are able to articulate their understanding of the problem solving process, information gathered from research, and its relevance to the task of the problem solving and the proposed solution. And this is one of the critical roles of instructor. And as I already mentioned, the problem posed initially may or may not remain unchanged during the learning process. For example, the instructor realizes for the group the problem is too simple or too complex, he should be able to adjust the scope of the problem accordingly. That means the problem, what is started initially, may not remain the same. And also, you should be able to sense when the students are getting stuck, are not able to move forward, and and accordingly, the process should be modulated by the instructor. This kind of thing will come with some experience for the teachers rather than right in the beginning. In the beginning, there will be a lot of struggle. Possibly, you have to take the help of some outsiders to ensure that the processes are understood properly with respect to some specific problems concerned with that department. Assessment, as we are part of this assessment course, both formative and summative is critical activity in any education system and is particularly important and complex in the case of PBL. And assessment must be aligned to the intended outcomes. This we have been saying right from the beginning of this course, namely, assessment should be in complete alignment with the outcomes. You cannot do assessment unrelated to your course outcomes or whatever intended outcomes. What is to be assessed? Knowledge and skill in the relevant domain, problem solving skills, and metacognitive thinking. So all of them will have to be assessed. Summative assessment of the final solution presented by the student teams in whatever format specified may require experts and appropriate rubrics. That is where our rubrics will come into picture. And one important thing is if every student tries to maintain a what do you call a reflective journal, like every time the group members meet, at the end of that, the student should be encouraged to write their own impressions, their own views, their conclusions, and so on for themselves. The reflective journal will facilitate the students to kind of articulate very clearly to what extent where they are facing difficulty, what extent they have learned, what are the other lessons they have gained in terms of group discussion and so on. And these experiences will vary across the institutes. It depends on the culture of the institute as well. So there is no unique way, and each institute need to evolve assessment methods best suited for them. While you can learn something from other institutes, you cannot just one-to-one copy. It depends on your culture or culture of your department or culture of your institute. Another important thing I have mentioned already is debriefing. This debriefing stage should not be skipped. It is essential for the benefits of PBL to be realized. They will help learners to recognize, verbalize, and consolidate what they have learned. As you can see, with all this, an exercise in PBL will try to fill all the gaps that normally that exist in current day education system, and it is not an afterthought. So you have to give experience to the students, and that can only happen through debriefing. And also the debriefing should help learners integrate the new knowledge with previous knowledge. And you should also, after the students have integrated their knowledge, maybe you can do some kind of ask the students to make a presentation or create a what we call as a concept map, which has been explained in the earlier courses. Most important thing, where do you use PBL? I've seen some institutes where they were trying to use PBL in every course in a semester, and it becomes a impossible thing for both the students and faculty. As we mentioned, the instruction of PBL is not efficient at all in terms of time as well as human and other resources. So, my suggestion is that you have one PBL exercise per semester should be more than adequate. But which course should have this? As the workload of the concerned faculty member will be high, a different course can be selected in each semester. So this again calls for a faculty group discussing and working out a schedule. Okay. Because everything requires considerable planning of resources. But once you go through this cycle of all the, let us say, every 6 or 7 semesters that you do, then what happens, it becomes a kind of starts becoming a second nature to the faculty as well. And they can keep on accumulating the number of problems and its resources. That way it will become a great, contribute a great deal to the faculty themselves. Okay. Here we need to create a set of rubrics for summative evaluation of PBL experience. So we'll first identify which can be the key characteristics. We may not be able to address all the key characteristics in a given rubrics, but at least we'll first find out which are the key characteristics of PBL. Problem identification and engagement. In a PBL, the problem is often ill-structured or open-ended. Evaluation starts with how students engage with the prompt. That is, when you have a ill-defined, ill-structured problem, how do you deconstruct the problem? Can you remove the vagueness? As I said, that takes considerable time. And also, if you make mistakes here, subsequent solution also can become difficult or unacceptable. And in that, the students will also have to identify what is the gap in their knowledge related to the problem. Sometimes it can be outside their particular discipline to understand that. Can they identify what they do not know and need to learn to solve the problem? Then the scope definition, defining the boundaries of the problem within the specific course context. Okay, that is what you have to identify at this stage. Then second key characteristic is self-directed learning that addresses both PO1 and PO11. Because PBL requires students to find their own answers, assessing their learning autonomy is crucial. Have you found your own way of answering some questions? Like what sources have you used to, credible sources you have used to come with the answers? It cannot be simple generic internet searches. It has to be based on credible sources. And information synthesis, how well do they integrate new knowledge with the concepts taught in the class? And then lifelong learning, sorry, that is not PO12, but that is PO11. Evidence that they went beyond the syllabus to find a solution that needs to be found and addressed. Then the third key characteristic is investigation and analysis. This is again PO2 and PO4. As you can see, PO2 can only be addressed through this kind of problems and projects, not generally through standard courses that we offer. This aspect evaluates the depth of their inquiry, analytical modeling, alternative solutions that you produce, and also feasibility analysis. Whether your solution is can it be implemented? Is it feasible or not? Then fourth key characteristic is collaborative problem solving. And you should always remember that is PO8. That means you are working, PO8 is related to team activity. PBL is inherently group activity. Peer contribution, using peer assessment forms to verify that every member contributed to the research and solution. If you really go through 2 or 3 such properly designed PBL exercises, you are preparing yourself extremely well for the placement. And your quality of discussion also should be appropriate, not mere bickering or making affirmative statements all the time. And then, for example, role rotation also you can try. That is, in each one, each student can change his role in the group a little bit. Then fifth key characteristic is application of modern tools. Are you using state-of-the-art hardware or software tools? And and you should be able to explain why such and such a tool is appropriate, because sometimes if you use the tool wrong, you will get the wrong answers as well. Okay, it is not merely like a because this is what is being used by others, so I will use that particular software tool. No, you must understand the the desirable features of a tool as well as its limitation. Then sixth is solution, defense, and communication. This is related to PO9, that is communication part. PBL evaluation often culminates in a presentation or a poster rather than thick thesis. So either you make a presentation, or one of the things the faculty can try is make the students prepare a poster on that. That is also a good experience for students. Can they explain the solution to a peer who hasn't worked on the problem? That is, you can try out with your classmates. The students can try out with their classmates who has not associated with the problem, and make sure whether they understand your solution, your way of doing. You can get the feedback from other groups as well. And the student should be able to defend why you chose a particular parameter using engineering logic. And also, one of the things is critical component of PBL is a reflection report where students document how their understanding of the concept changed during the process. So these are the critical key characteristic. Last one, societal and contextual knowledge. That is related to PO6, because PO6 is considered very important by NBA. If you can incorporate that, it will be good. Depending on the course, the problem might have non-technical constraints. Contextual relevance. If the problem involves designing a water filter, did they consider the cost for rural users? That is the kind of, let's say your problem is to design a water filter. Now, it may work out for urban users, but does it work for rural users? Can you explore that? That is the contextual relevance. And then sustainability. For example, if something needs to be changed every month in a filter, then obviously it is the life cycle of the materials proposed is wrong. So PO6 kind of thing identifies these issues. Have you paid attention to these issues is the requirement. Now, out of the 7, I have chosen, as I said, this 5 I have selected is not unique. If you consider something else is more important, please go ahead and do so and correspondingly change the rubrics. Now, before we identify the rubrics, we will first identify the dimensions. Problem identification and engagement, it will address PO1 and PO2. PO2 is very important. Self-directed learning, PO11 and PO1. Investigation and analysis, PO2 and PO4. Collaborative problem solving, PO8. And solution defense and communication, PO9. As you can see, you are addressing fairly large number of program outcomes through a PBL exercise. Even if you alter, still it will be a fairly large number. Here we have 2, 3, 4, 5, 6 POs out of the 11. Okay. Now scoring ranges are again, I am using excellent, good, average and poor, 10 to 9, 8 to 6, 5 to 3, 2 to 0. Now, once again, like the earlier one, I will try to how to do the best so that all groups should aim at performing excellently. If you fall short of that, yes, you may get a slightly lower marks, but at least you should attempt to do this. Problem identification and engagement, that is 20% weightage. We have given same weightage to all the 5. The student team formulates a sharp, unambiguous problem statement, identifies all relevant engineering constraints, technical and environmental, etc., and underlying principles accurately. Deconstructs the ill-structured problem into solvable engineering modules effectively. So if you are able to do that, then you are performing this, you are meeting this key characteristic excellently. Then the second one, self-directed learning, demonstrates extensive exploration beyond the syllabus. These days, exploration becomes much simpler, courtesy Google or let us say now these days AI as well. But it should be based on really authentic resources. But it will reduce considerable amount of time of your searching journals and books in the library, because it can quickly lead to some credible resources if you use any of these tools. Uses high quality resources like IEEE papers, BIS, ISO standards, and technical data sheets. Successfully synthesizes new information to bridge knowledge gaps independently. Third one is investigation and analysis. Excellent is applies advanced mathematical models or engineering principles to analyze the problem. Explores multiple alternative solutions and justifies the final choice with the data and calculations. Feasibility analysis is comprehensive. If you do all this, investigation and analysis becomes excellent. Fourth one is collaborative problem solving. All members contribute equally and substantively. Evidence of high-level collaboration where members build on each other's ideas. This can get reflected through reflective journal as well. Conflict is managed constructively. That is one very important characteristic in professional life. Roles are clearly defined and executed. Then solution defense and communication. Presentation is logical, engaging, and professional. The report is well structured with project citations, can confidently answer probing technical questions and defend design choices with evidence. See, now even creating a good, well-structured document is relatively easier compared to the earlier period because of the availability of AI tools. So, with respect to each dimension, you give some marks out of 10, depending on where exactly this group has performed. Okay, and then you sum all that up by using this formula: 0.2 of ds1 plus ds2 plus ds3 plus ds4. Sorry, there is a zero that came, which is not appropriate. ds4 plus ds5. So as you can see, there is a whole lot of experiences that you go through, which you normally don't go through in a what do you call a completely lecture-based course. All these are to be learnt outside the formal course. That's why it becomes very important to incorporate at least one experience per semester. Okay. I hope I'm able to convince you about the importance of PBL. And thank